indivisible, the atomic theory. So the idea of atoms has been around for a long time. Back in the 5th century BC, Leucippus and Democritus. These guys recorded some of the first ideas of atoms. Democritus suggested that if you divided matter into smaller and smaller pieces, eventually you would end up with a piece that was indestructible. And these guys didn't do experiments, they were philosophers. They sat around and thought about things. So that's an interesting idea. You know, if you took, say, a piece of gold and you cut it in half, and then you took that half and cut it in half. If you've taken calculus, you know they do stuff like that mentally, breaking things down into infinitely small pieces. Could you keep cutting it infinitely? Or is there some point at which you reach the smallest particle? And way back, 300, 400 BC, they were thinking, I think there's a smallest piece that you couldn't cut it further. They couldn't test that, though. They didn't have the knowledge or the equipment to do that. But Democritus called those pieces atomos, or atoms, and that means indivisible. 2,000 years later, Dalton's atomic theory. Dalton's atomic theory states that each element is composed of tiny indestructible particles called atoms. We now know that those particles are not completely indestructible. In a nuclear reaction, atoms can be destroyed, but in a chemical reaction, they cannot. All atoms of a given element have the same mass and other properties that distinguish them from atoms of other elements. And we've also learned something about that that's a little not quite true. So some atoms of the same element actually do vary a little bit in mass, and we'll learn more about that later. But atoms of different elements are different from each other. And the other postulate in his theory was that atoms combine in simple whole number ratios to form compounds. And these are really important ideas. This is a theory. This is trying to explain why, not state what happens. Law of conservation of energy is a law. It says energy is conserved. It doesn't explain how or why. It just says this, we observe, this is what happens. This is an attempt to explain. Different books show different pictures like this. Your book shows this picture from IBM. This is a picture of xenon atoms taken with a scanning tunneling microscope. These are xenon atoms, and they moved them around and arranged them to spell IBM. Aren't they clever? Now, that does not mean that atoms are shaped like little cones. This is the best picture that we can get of atoms. Atoms are not shaped like cones. So this is, kind of a fuzzy, distorted picture. But we have evidence, physical evidence, of actual atoms. So that's kind of cool.